Hi friends, welcome to our Genius Maths classes. We are class PUC second year, subject mathematics, and the chapter is relations and functions. So till today we have discussed the basic concepts like relations and types of functions. So in the previous class we have discussed about the functions, okay, on-one, on-two function and bijective function. In this class I am going to discuss about composition of function, and invertible function. In this class I will discuss about composition of function and invertible function. Okay. So this is very simple concept. Both are very simple concept. Okay, composition of function and invertible function. Let me first explain about composition of function. Okay, composition of function. So this is very simple concept. Okay, so composition of function means it contains more than one function. Okay, or else the function inside the another function. You can also call it as function inside the another function, and I will denote it as f not g. F not g. Okay, and using the parameter x, you can define it f not of g, which is equal to f of g of x. That means the g function which is contained in another function f. So you have to define both these functions. So how this concept comes? And I will explain a simple concept. Packing of water bottle. So packing of water bottle. So if you have water bottle, empty water bottle. So this is a water bottle, empty water bottle, and you have to pack it. Empty water bottle, and you have to pack it with the water. Okay, the first function is to fill water. In this bowl. Okay, the first function is filling the water. Okay, so it needs to fill up with the water. So first function is filling the water in it, and second function F2 is closing with the cap. And second function is closing this bottle with a cap. So combining these two functions, we will get a packed water bottle. Combining these two, we will get a packed water bottle. So this is the concept of composition of function. That means more than one function will give you the result. That means to obtain this packed water bottle, we need to first fill up this water bottle and then closing this water bottle with a cap. These two are the functions to get the packed water bottle. This is the concept of composition function. So we have many other real world example for the composition of function. For example, extracting petroleum materials. Okay, petroleum materials. We want to get petrol, diesel separately. First, we need to extract the petroleum. Okay, first we need to extract the petroleum. Okay, then after refining, by these two processes we will get a petrol, diesel and etc. Okay, any extra materials, for example the wastage materials, any other extra materials. So we need to first extract it and then refining it. So extract and refining. So using these two, you will get petrol, diesel, etc. Okay. So this is nothing but the concept of composition function. Okay. Now using that concept, I will define the composite function. Okay. The definition: composite function, let f from a to b and g from b to c. These two are function. F is function and g is function. and it is mapping from A to B. F is mapping from A to B, and G is mapping from B to C. Okay, so these two are the functions. Okay, then the composition of two functions is denoted by, now I have to define this. So composition of these two functions f and g is denoted by g naught f. G naught f is defined as the function from g naught f. It is defined as a function g naught f from here to here, from A to C. From A to C. Combining these two will give the mapping from A to C, and it is given by g naught of f of x equal to g naught of f of x equal to g of f of x. So this is the composition of function, and for all x belongs to A. Okay, ಏನಾಗುತ್ತೆ f ಅನ್ನೋದು function and g ಅನ್ನೋದು ಇನ್ನೊಂದು function. These two function and composition of these two function is denoted by like this, g naught of f. Okay, using this, and it is defined as a function g naught of f. This function is mapping from A to C, because f is from A to B and g is from B to C. So these two will give you the mapping from A to C. A to C. It is given by g naught of f of x equal to g of f of x for all x in A. So this is a pictorial representation. So this is the definition. This is a pictorial representation. Okay. If you have x in A, if you have the element x in A, then if you apply function f here, okay, this is the element in A. If you apply the function f, the image of this x will be f of x. ಹೌದಾ? Element is x ಅನ್ನೋದು A element ಅದ. Okay, and we are defining f from A to B. Okay, the image of this function f for this x will be f of x. ಹೌದಾ? Okay, so now defining g from B to C. Defining this g from B to C. Now this f of x is element in B. This f of x is element in B, and we are defining function g. G of, so the image will be g of, g is a function and the element is f of x. Right? Element will be f of x. So this is the composition of function. The element exists in C will be g of f of x. The image is g of f of x. This is nothing but the composition of this function. This is nothing but the composition of this function g naught of f, that is equal to g naught of f of x, which is equal to the image is g of f of x. G of f of x. So this is a concept, simple concept. Okay. So this is nothing but the concept of composition function. Let me solve some examples. First example is, let f, I am defining f from 2, 3, 4, 5 to 3, 4, 5, 9. This is a function I am defining from 2, 3, 4, 5 to 3, 4, 5, 9. Okay, and another function g, 3, 4, 5, 9 to 7, 11, 15. So these two are function, and I am defining this function as defined as f of 2 equal to 3. F of 2 equal to the image of 2 under f is 3. The image of 3 under f is 4. The image of 4 under f is 5, and image of 5 under f is 5. That is nothing but f of 2 equal to 3, f of 3 equal to 4, f of 4 equal to f of 5 equal to 5. So this is the function of f. And now function g. G of 3 equal to g of 4. So this function g is defined from 3, 4, 5, 9 to 7, 11, 15. Okay. So they are defined as g of 3 equal to g of 4 equal to 7. Given. And g of 5 equal to g of 9 equal to 11. So this is the function g. So now you need to find out g naught of f. G naught f. So solution is, let me solve this problem. The solution is Just observe here, f from 2, 3, 4, 5 to 3, 4, 5, 9. Okay, this function f is defined from here to here. Right on. Just draw the picture. 2, 3, 4, 5. Okay, so this is mapping from here to where? This 3, 4, 5, 9. Okay, so this is a function f. F is defined from this 2, 3, 4, 5 to 3, 4, 5, 9. So f of 2, according to this f of 2 is 3. So I am marking this. F of 2 is 3. And here f of 3 is equal to 4. F of 3 is equal to 4. And again f of 4 equal to f of 5 equal to 5. So under f, the images of 4 and 5 is same. The images of 4 and 5 is same. Now this function f is over. Now come to the function g. So g is defining from 3, 4, 5, 9 to 7, 11, 15. Draw another set, that is 7, 11, 15, and function is g. Okay, this is another function g, and its images are g of 3. So this is g of 3, g of 3, and g of 4. So images of 3 and 4 are same. 3 goes to 7 and 4 goes to 7. Similarly, g of 5 equal to g of 9 equal to 11. Similarly here, images of 5 and 9 are same. Okay. So one thing is here, just observe here. Okay. F of, and you have to calculate this g of f. Okay. Just observe here. This is f of 2. The f of 2 equal to 3. Okay. And now g of 3 equal to 7. You need to find out g of f of 2. First one. G of f of 2. Okay. The first element is 2. Therefore, I am finding the composition of 2. The element 2. Okay. Right on. G of f of 2 is can be written as g naught of f of 2 is equal to g of f of 2, and we know the value of f of 2. F of 2 is here. F of 2 is equal to 3. Therefore, g of 3, and we know the value of g of 3. So g of 3 is equal to 7. Here, g of 3 is equal to 7, and therefore the composition function g naught of f of 2 is equal to 7. Okay. Second one, g naught of f of 3. So we need to find out the composition function of the element 3 here, and this is can be equal to g of f of 3, and we know the value of f of 3. F of 3 is equal to 4. G of f of 3 value is to there 4, and we know the value of g of 4. G of 4 here is equal to 7. Here g of f of 4 equal to 7. Similarly, f of g naught f of 4. G naught of f of 4. It can be written as, according to the definition, f of 4. Okay. The f of 4 value is the 5. So g unguided keep as it is, and f of 4 value is 5. So we know the value of g of 5. Okay, we know the value of g of 5. So g of 5 value is 11. Okay, and fourth one is g naught of f of 4. Okay, g naught of f of 4, and g naught of f of g of f of 4, and g of 5. F of 4 value to the f of 4 value. So f of 5. F of 5. F of 5 value is 5. So g of 5 is again 11. So this is the composition function, and this is the solution. This is the g naught of x. For all the values, your x, for all x here, 2, 3, 4, 5. The result is same. The result is like this. So this is the solution of G naught of F. Another example. Find G naught F and F naught G. Okay, we have to find here G naught F and F naught G. If F from R to R and G from R to R, that means F is defining from real numbers to real number. Okay, this set is real set to real. The function is defined from R to R and G is defining again from R to R. That means real number to real number given by f of x equal to cos x. So this function f of x is cos x and g of x is 3x square. So both our functions are given. This is cos x and this one is 3x square. So we have to show that g naught of f not equal to f naught g. That means this doesn't satisfy the property, commutative property. So g naught of f not equal to f naught of g. So let me solve the example. Solution given. What is given? The function f from real number to real number and defined as f of x equal to cos x. So this f of x is cos x. Another one is g. G is defining from R to R and this is given by g of x equal to 3x square. Okay, so let me first calculate g naught of f. So g naught of f here, g naught of f of x, g naught of f of x, which is equal to, according to the definition, g of f of x. Okay, so we know that f of x. So what is f of x? F of x is cos x. Therefore, this is equal to g of f of x is cos x. Given f of x is cos x. Okay. Now we need to find out g of x. What is g of x? G of x is 3x square. Okay. G of x is 3x square and f of x is cos x. It is given f of x as cos x. Now we need to find out the function g. So in the place of x, there is cos x. In the place of x, there is a cos x. Therefore, we need to change x by cos x here. Okay. So what is g of x? 3x square and this one is 3. In place of x, there is a cos x. Therefore, this will become x square, that is cos square cos x whole square. That is 3 cos x whole square. Right? This is g naught of x. G naught of f of x is, take it as question 1. G naught of f of x equal to 3 into cos x whole square. Okay. Now find out this one. F of g. Second part. Next, f naught g of x. So by the definition, it can be written as f of g of x. So we know that g of x is 3x square. We know that g of x is 3x square, and therefore we can write f of g of x is 3x square. Therefore, f of 3x square. Okay. So now we need to find out the f of 3x square value. So here, in place of x, f of x is cos x. So here, in place of x, we got the function cos x. So here also we need to change apply for 3x square. So if f of x is cos x, in place of x, it is 3x square. Therefore, it becomes as cos of, in place of x, this x, here in place of x is 3x square. Just to replace x by 3x square. That is cos of 3x square. So this is f naught of g of x. Okay. Just observe here 1 and 2. 1 and 2. This is g naught of f of x equal to 3 cos x whole square 1. This is case 1. And f naught of g. F naught of g of x equal to cos 3x square. But observing these, are they equal? No. 3x square is different and cos 3x square is different. Therefore, we come to the conclusion that g naught of f of x, which is not equal to f naught of g of x. In general, g naught of f not equal to f naught g. This is the solution and this is the solution. So come to another example. Show that if f from a to b and g from b to c are 1, 1. So here given that function f and function g both are 1, 1, and then we need to show that composition function g naught of f that is defined from a to c is also 1, 1. Here f is 1, 1 function. We very well know about 1, 1 function. So we have discussed the types of function in our previous class. Just go through it, and if you need to prove this is 1, 1, then you must satisfy the condition that if f of x1 equal to f of x2. So if this is the case, then you must satisfy that x1 must be x2. Okay. F of x1, both functions are equal, then elements must be equal. So this is the thing for proving 1, 1 function. Okay. So here let me solve this. So both f and g are 1, 1 function. Okay. Then we need to prove that g naught of f from a to c is also 1, 1 function. Proof. So given that, what is given? Given that f from a to b and g from b to c are 1, 1. 1, 1. Now we need to prove. Now we need to prove that g naught of f from a to c is also 1. Okay. So when we have 1, 1 function, then this function is 1, 1. Okay. So let me write g naught of f of x1 equal to g naught of f of x2. If these images are equal, okay, these two functions are equal, then we must prove that x1 must be equal to x2. x1 must be equal to x2. Then only we can that composition is also equal. So write down. So by the definition, what is that? G of f of x1. Okay, by this function g of f of x1 and this one g of f of x2. So this is by definition. And we know that g is 1, 1 function. Here given g is 1, 1. Given g is 1, 1, and therefore this implies that. Okay. So g is 1, 1 and f is also 1, 1. F of x1 and g are also 1, 1. F and g both are 1, 1 function. Now from this f of x1 is 1, 1 and therefore this is also 1, 1. Therefore this will give you that f of x1 equal to x1. Why? Because this f is 1, 1. This is also 1, 1. Okay. Now again g is 1, 1 function. G is 1, 1 and therefore x1 equal to x2. So if the functions are equal, then images are equal. This satisfies that this holds the property 1 1 function. Why? Because this G is 1 1 function. This is already given in the example. Why? Because this one f is 1 1. F is also 1 1, G is also 1 1, and therefore G naught of f from A to C is also 1 1. So this satisfies that G naught of f is also 1 1. So this is this solution. Okay, next similar example. Okay, similar example. Just similarly we have proving if f is 1 1 and G is also f is onto and G is also onto, then composition G naught of f is also onto. So we need to prove this. Okay, the onto function is every image it must have the pre-image in its domain. So here given solution is f and G are also onto, then we need to prove that G naught of f is onto. We need to prove this. Okay, so here, so just consider some diagrams. A, B, C. So from A to B, f is defined. From B to C, G is defined. Okay. As they said, f is onto and G is onto. Okay. They have said f is onto and B is onto. So just consider some elements here. Okay. So x belongs to A, so y belongs to B, and z belongs to C. So we need to prove that if there exists a z in C, okay, it must have the pre-image G of y. So if z belongs to C, you must prove that G of y equal to z, because z has a pre-image G of y since G is onto. Similarly, y belongs to B, it must has a pre-image. Okay, therefore f of x equal to y, because f is a onto function. So by this we conclude that G naught of f of x, which is equal to G of f of x. Okay, so what is f of x? G of y. F of x equal to y, and therefore G of y equal to z. So we overally constructed that G naught of f of x equal to z. G naught of f of x equal to z. Overally we consider that this is onto function. Why? Because G naught of f of x, it has a image in z. Its image is z. Therefore, this is the onto function. Okay. So this is the theme of this theorem. Why? Because for z belongs to C, it must have a pre-image in B. Therefore, G of y equal to z, because G is onto function. For some y belongs to B, it must have a pre-image in A. Why? Because f is onto function. Therefore, f of x equal to y, and G naught of f of x equal to G of f of x, that is equal to z. So G naught of f of x equal to z. This is proves that G naught of f is onto function. This implies that G naught of f is onto. So this is the solution. Then composition is also onto. Okay. So just think in a reverse way. If f naught g is 1 1, then does f and g are 1 1? Does f and g are 1 1? And similarly, think if f and g are onto, if f naught g is onto, then does f and g are onto? Just think it. Okay, just think it and verify it. Okay. Let me solve another example. Let's look at it. Let f from 1 to 3 to ABC. We are defining the function f from 1 to 3 to ABC. V-Jnana and onto function. Okay, so we are defining this function. This is V-Jnana and onto function. So this is given by f of 1 equal to a, because 1 has the element a, f of 2 equal to b, f of 3 equal to c, because this is V-Jnana function. So each element here has a different images, that is 1 1, and each element here has a 3 images, therefore it is 1 1 and 1 2. So that there exists a function. So with that we have to show that there exists function g from abc to 1 2 3, reverse of that, g from abc to 1 2 3, such that composition g naught of f equal to ix, okay, and f naught of g equal to y, where x equal to 1 2 3 and y equal to abc. So what is ix? Is identity element on x, where is ix identity set on y. The identity set on x is identity set on y. So when we are composing g naught of f, we get identity set on x, and when we are composing f naught of g, we will get the identity on y. So x equal to 1 2 3 and y equal to abc. Here we need to show that this function, okay, observe here, f is defining from 1 2 3 abc and g. So we have to show that g is defining reverse abc to 1 2 3. Okay, so just observe here, using this concept I can define g, okay, g, and this composition will give you the identity. Okay, with this I can conclude one definition. So let me write this. So g from abc to 1 2 3. Okay, and it is defined by g of a equal to 1, g of b equal to 2, and g of c equal to 3. Okay, also given that f. Also given f from 1 2 3 to abc. Okay, they give 1 2 3 to abc the function, and we need to show that there exists some function which is reverse mapping abc to 1 2 3. So that is why I have defined g of a equal to 1, g of b equal to 2, g of c equal to 3, which is also 1 1 and on 2. Now just it is given as f of 1 equal to a, f of 2 equal to b, and f of 3 equal to c. It is given in the example. Okay, now we need to show that g naught of f equal to ix and f naught of g equal to I. Okay, let me show this. First, consider g naught of f. Okay, g naught of f. So f has 1 2 3. That means identity function means element should have the same image. Identity element should have the same image. For example, f of x equal to x. Okay, f of x equal to x means it has the identity function. That means f of 1 equal to 1, f of 2 equal to 2, f of 3 equal to 3. Everywhere it is same image on 100/2. The identity function, because 1 has a 1 image, 1 ಗೆ 1 ಬಂದೈತಿ, 2 ಗೆ 2 ಬಂದೈತಿ, 3 ಗೆ 3 ಬಂದೈತಿ. That is why this is the identity function. Similarly, here if I consider g naught of f of 1, it must has the image as 1. G naught of f equal to n ಬರಬೇಕು 1 ಬರಬೇಕು. Okay, so by the definition, g naught of f, g of f of 1. Okay, g of f of 1. So this g of f of 1, and we know the value of f of 1. F of 1 is value is a. Therefore, this is g of a. So what is g of a? G of a is again 1. Okay, by this we have seen that g naught of f of 1 equal to 1. That means the image has this element has the same image. This one has the same image as 1. So that is why we got the element image as 1. Now consider for 2. G naught of f of 2. G of f of 2. So f of 2 value b. So g of b. Therefore this value. So this 2 has the image 2. Okay. G naught of f of 3. G of f of 3. So what is the value of f of 3? F of 3 value is c. G of c. So g of c is equal to 3. So by this we got the images as 1, 2, 3. 1, 2, 3. Okay, this identity function is this identity function. For 1 value you got the 1. For 2 you got the value 2. For 3 you got the value 2. So that is nothing but 1, 2, 3, which is x. Okay, and therefore G naught of f of G naught of f has ix. So identity element of x. Okay, so this one is proved. This one is proved. Similarly, we have to prove f naught of g. Similarly, we have to prove f naught of g. Okay, f naught of g. G has the images a, b, c. Therefore, f naught of g of a. By definition, we can write f of g of a. Okay, f of g of a. G of a value is 1. F of 1. So f of 1 is equal to a. So here also we are getting the same images for a same element. So if we have this function f naught of g of a, we got the image as a only. So this is identity. This is identity function. Similarly, f naught of g of b, we got f of g of b. So what is f of g of b? F of g of b's value is 2 and f of 2 value is b. Similarly, f naught g of c, we are getting f of 3. F of 3 value is c. So for every element here, we are getting the image the same. Therefore, f naught g is equal to iy. Why? Y is ABC. Y images are ABC. That is why identity function. This is identity function. So by this thing, we conclude that it has the inverse function. It has inverse function. When it must be 1, 1 and onto function. It must be 1, 1 and onto function. Then only there exists a reverse function from this, from ABC to 1, 2, 3. This g is the obviously reverse of that function, and this is the inverse function, and this g is the inverse of f. So this concept is coming from this. When this function is 1, 1 and 1, 2, then only there exists the inverse function g. Okay, such that when you compose it, f naught of g, okay, then you will get the identity function. Then you will get identity function. This is the theme of this inverse function. Okay, now let me define inverse function.